My name's Dominic Wallerman. I have a PhD in physics. Physics tends to be quite a difficult subject, so it's always interesting to see how in the movies they interpret physics, because it's sometimes good and sometimes a bit wonky.
What are we looking at?
These neutrinos acting normally. Minuscule mass, no electrical charge. They pass through ordinary matter almost undisturbed.
Okay, so what they said there was that neutrinos normally, they come from the sun, they normally don't interact with matter, so they go through the earth without actually interacting with anything, which is totally true. 10 billion go through every square centimetre of your body every second.
It looks like the neutrinos coming from the sun have mutated into a new kind of nuclear particle.
Now the neutrinos have mutated into a new kind of subatomic particle which interacts with the core of the Earth, heating it up. That would be groundbreaking discovery in terms of like the fundamental theories of physics, which would be awesome. It would suck that the Earth was boiling from the inside, as you could see from that big tank of water. Bad design of spacesuit if it's that easy to take out the critical air supply to your head. So I don't think your head would actually explode if you're on Mars and you got depressurized. I think you'd suffocate because all of the air would get sucked out of your lungs. Your blood would boil, so you'd get the bends, and yeah, things would really not be good. You would not last long.
Down!
Ew. So he dried out. He desiccated. I'm not sure actually you would lose all the moisture from your body that quickly. Is that more realistic than your head exploding? Yes. Yeah, this is a classic. Someone falling down and then someone comes along and saves them by smashing into them like a freight train. So actually the first two, the Superman films, they did it pretty well. It seemed like the catch was pretty gentle.
Easy, miss. I've got you.
But with the Batman one, those two humans are going to get snapped by that cable, because it was like a metal cable with no flex in it whatsoever. So as soon as that catches on the building, they're just going to go... They're going to break all sorts of things. I mean, probably Batman's arm's going to get ripped off. Oh, that Batman movie is so good. I think that might be the best one. I guess the question is that how mathematicians actually solve mathematics? It tends to be a lot more argumentative than that, I would say. Normally it would be someone draws out the problem and they try and explain it to us. Different people will interpret it with different levels of confusion. And then at some stage someone gets it and is like, oh yeah, I know what you're doing. Now I can try and solve it. And then actually solving things right then and there in front of a blackboard, I think rarely happens. Mostly you have to go away and think about things really, really hard. Rather than you having these coy little glances to each other and being like, ooh, I know the answer.
Whatever the signal is, we better do something soon. Vega's gonna set.
Deposition is confirmed. We've got 4 points.
When they're doing measurements of astronomical objects, you can't always rely on just a single measurement from a single telescope because there can be systematic errors. So people like to have many different sources, many different measurements of the same source. And so that's come up recently in gravitational waves. They have 3 different gravitational wave detectors, 2 in America and 1 in Italy. And so they can kind of triangulate a certain region, and then they can look at it using the electromagnetic spectrum. And I imagine a lot of the science in contact has been very well researched, because it was written by Carl Sagan, who is obviously a giant in communicating science. He wanted a realistic mechanism to transport the protagonist to Vega, which is on the other side of the galaxy. And so they thought about it and they came up with the idea of wormholes, stable wormholes, which are actually allowable in Einstein's general theory of relativity. So you can have basically a tunnel of space-time that goes from one point to the other. So Carl Sagan basically nerd-sniped a load of theoretical physicists with this question, because then for decades they've been working out like how these wormholes, these stable traversable wormholes, could exist. People have been trying to work out all of this stuff because it's just an interesting science question.
Imagine for a minute that this attractive piece of paper represents space-time, and you want to get from point A here to point B there.
Like the visual example of the bit of paper with the thing going through it, I think that's totally cool.
It folds space. When the spacecraft passes through the gateway, space returns to normal.
It does fall down in terms of actual science. What he said was he used magnets
Use a rotating magnetic field
to make gravitons.
to focus a narrow beam of gravitons. These in turn fold space-time consistent with Weyl tensor dynamics.
And then the gravitons would warp space-time. So those two are different forces, and so there's no known way that you could create gravity using magnets. Now, if you created, let's just say you created gravitons, and creating gravitons somehow warps space-time, technically you're just becoming like a really giant mass, a black hole or something. So if you warped space-time where you are, all of the things around you would start wanting to fall into you. And so that might be problematic for your spaceship.
We're used to viewing space as flat, right? Like this piece of paper.
Yeah,
To see something from a distant flight has always had to travel a long way across the flat space in between. But given what I was trying to explain, we could fold the space.
So this concept, I didn't realize this concept has turned into a bit of a cinematic cliche. A good reason that like the original film had created like a really nice visual image for something, which, you know, there's something to that. So one thing that I really liked about that is when the lady said, "Oh, we've spent a huge amount of energy on this."
We used huge amounts of energy to create this bridge.
All right, but why can't I see this bridge?
So yeah, the amount of energy you would need to expend to make one would be equivalent to creating a black hole, which is like the remnants of an explosion of the largest, most energetic bodies in our universe. So yeah, you're going to use a little bit of energy on that one.
So they say you want to go from here to there.
It's turned into a real cliche, hasn't it?
So a wormhole bends space like this.
So when they were going towards the black hole, the fact that you could see things reflecting off the surface, almost like galaxies and stars were like reflecting off it, kind of like it's a mirror. I mean, that's not technically correct. They are black because anything that falls into them disappears. But you know, that's fine. They need to show something, otherwise you don't know what you're looking at as an audience. So like that's totally fine. Like I love that visualization of how, from your perspective, what it would like for all of everything you see around you, like warp around yourself. That was really cool. I really enjoyed it. I have other problems with Interstellar apart from that, but that bit of it I think was really, really good.
And it's a dead heat. They're checking the electron microscope, and the winner is number 3 in a quantum finish.
No fair! You change the outcome by measuring it.
In quantum physics, when you measure something that's in a superposition, which is the special state where it's in like this special mixed state, kind of like two states at once, before they measure it, both horses are in a superposition of winning and not winning at the same time, and then they measure it, and then one of it comes out. But according to theory of quantum physics, if you measured that again, you might get the other one. So each time you measure it, you get one winning or the other one winning 50% of the time. So yeah, they got it bang on, and it's also a really funny joke. I like their hats. They're special space hats. They keep your brain in when you explode. On the Apollo missions, for sure, they had little food packets with straws in it. Generally, you want to avoid loose food floating about. I remember one astronaut got into a lot of trouble for bringing a ham sandwich onto one of his space flights, and they were really worried about the crumbs getting out and frying the electronics. Oh my god, the thing, like 2001 is good, but it just takes so long for anything to happen. I don't fall asleep in movies. I've fallen asleep in this movie twice on 2 separate occasions. Yeah, it was good. Boring movie though. Sorry. I know people love 2001, but
Gotcha.
So Gravity got a lot of things right, but this one thing is kind of the glaring problem in the whole film.
You have to let me go.
No.
The ropes are too loose. I'm pulling you with me.
What would happen if they were connected by this tether and he gets pushed outwards? That totally could happen. But as soon as it gets taut, he would bounce backwards again, and he would just gently drift back to her, and then they'd go back to the space station. So he would have been absolutely fine. I'm okay with bad physics in movies, because the job of a movie isn't to be a science documentary. The job of a movie is to tell an interesting story. I just feel like they could have come up with some much better physics thing. But still, it's so frustrating when a film does so much stuff really correct, and then you've got this one thing that is like, ugh.
We have a signal on the luminosity monitors. We have events.
Whoa! Firework noises. Man, that looked so cool! I really wish like all of physics could be explained using that kind of visualization, like cinematography. They were talking about suspending antimatter.
The antimatter is suspended there.
Using nanoparticles and electromagnetism.
In an airtight nanocomposite shell with electromagnets on each end.
That's all good. I mean, the nanoparticles, they just put that in because nanoparticles sound cool. But the containment of antimatter, you do have to do an electromagnetic field. I think the things they actually use are a lot bigger than that, because the magnets that they use have to be giant. Antimatter, if it combines with matter, does like explode in tons of energy.
But if it were to fall out of suspension and come in contact with matter, then the two opposing forces would annihilate one another violently.
But typically the amounts of antimatter that they store places like CERN are so small, I don't think you'd get a massive explosion from it. The best bit is them running on a battery, which is going to run out.
Just before midnight.
Well, don't put your antimatter storage devices on battery power.
Prepare the red matter.
Oh, is that the guy from Westworld? I don't know, you get this thing with sci-fi films where they always have to raise the stakes. So there's kind of like an arms race of like the cool, crazy, super powerful stuff. They've got this magical red matter, and that a tiny little piece of this red matter, if you put it in the middle of a planet, it will create a black hole that will suck the entire planet into it. Just a tiny droplet full. Why the hell has this ship got so much of this red matter on it? Like, if you tripped and bumped into that vessel containing that red matter, you'd create a black hole big enough to absorb the entire universe or something. So yeah, I give it a fail. Eraser. Oh, I saw this film so long ago. Some X-ray if you had a telescope, you would be, for a start, just beaming out such incredibly high amounts of X-ray radiation that you're giving everyone cancer. And also, for you to see stuff, you have to have the detector of the X-rays at the back. So you fire X-rays through something, and then you get stuff at the back, and where the X-rays are absorbed, like by your bones, that's where you get the white bits, and when the X-rays come through, you get the black bits. Yeah, so that's not really physics. Railguns do exist. They accelerate bullets using electromagnetism, and in fact they've got massive giant ones that can... People have thought about launching things into space using railguns. So that's a legit thing. No! And that's why you don't use X-ray vision when you're shooting people, because you don't know who is Arnie and who's a goon.
Look at this. See? I'm right again. Nobody could have predicted that Dr. Grant would suddenly jump out of a moving vehicle.
So this is not a good description of chaos theory at all. He does explain it with the butterfly effect.
The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine.
So that is the essence of chaos theory. The whole thing about the water on the hand...
Aha, okay. Right. Okay, now freeze your hand. Don't move. I'm going to do the same thing, start with the same place again. Right. Which way is it going to roll off to?
I don't think that's the best description of it, because presumably if you have water on your hand, it will drip off the same way the last drop of water did, because it's already kind of wetted that bit of skin. So it's more likely actually that the water will go the same route that the second bit of water is.
Same way. Same way. It changed. Why?
But the point of it actually is that Jeff Goldblum's character is just hitting on Laura Dern's character in kind of a creepy way. So in actual fact, I think it's pretty realistic, because his character probably cares more about hitting on a chick than he does about getting the right explanation of mathematics.
43.
I haven't actually seen Armageddon.
Enough with this anomaly horseshit. What is this thing?
It's an asteroid, sir.
How big are we talking?
It's the size of Texas, Mr. President.
I mean, it sounds super scary. Some giant space rock could just turn up out of nowhere and slam into the planet. I think the one that caused the extinction of the dinosaurs was 5 kilometers wide. So I don't know how big Texas is, but it's way, way bigger than that.
We need you to prep the team we're sending up.
Up?
We'll send them to the asteroid. They'll land, they'll drill a hole, they'll drop some nukes, take off and detonate, if we can fix this equipment problem.
That's a really bad idea. If you do that, you basically turn it from like a single bullet into a shotgun blast. So then you've just got loads of slightly smaller asteroids that are all radioactive. Yes, it's a very real possibility. The probability of it is incredibly low. And it's interesting hearing the different ideas people have. Some are as simple as you go up there with a spaceship and you just paint one side white and the other side black. And if you do it early enough, it'll pick up enough solar radiation from the sun on the white side that it will actually deflect it a certain amount. And then what was another? Oh, another one was attach rockets to the side of it and then deflect it sideways to, again, deflect the orbit. Exploding with a giant nuclear bomb is not the best idea, I think. Painting it. But painting is not going to make an exciting movie. We have to paint it white.
I don't know, but they constructed this three-dimensional space inside their five-dimensional reality to allow you to understand it. Time is represented here as a physical dimension.
Like, the visualizations in that film are so cool. When you look in different directions, things line up, and so it looks like you can travel through different things, and that would be kind of so hard to kind of imagine higher dimensions and how geometry works. They had made time into a physical dimension, so as he traveled in certain directions, he could find the time he was looking for. But the thing that was navigating him through that higher dimensional space was the power of love.
Just like I found this moment.
How, Cooper?
The love towards love.
And that's the bit of the film where I was just like, maybe I'm just not sentimental enough. But, I mean, come on, guys. Seriously. Not to belittle love. I love love. It's good. But I feel like it actually ruins it to reduce love to some kind of physical physics. Physics is so basic. I have no problem with wonky science in movies. I even kind of enjoy it, to be honest, because it's fun to try and imagine the kind of things that they're saying. It can be kind of quite imaginative, actually, how you interpret it when they say things wrong. The problem I have isn't with bad science in films. The problem I have is bad films in films. Is this a military kind of installation? Because I find that there's often science and the military come together in these sci-fi movies, and the scientists are always like trying to explain things, and the military people are always just like, no, I need a yes or no answer now. I mean, geez, they control all the nuclear bombs. I hope they're not just like, don't give me your jibber jabber. Is it nuclear or not? Denzel Washington getting really angry about science.